Have you ever wondered how electric cars, the future of transportation, actually work? As we hurtle headlong into the 21st century, one thing is becoming clear. The transportation landscape is shifting beneath our feet, and electric cars are leading the way. Imagine a world where the air is cleaner, where the whir of electric motors replaces the roar of combustion engines, and where fuel pumps are as antiquated as horse-drawn carriages. That's the world electric cars are promising us. These machines, once considered the stuff of science fiction, are now a reality we see every day. They're sleek, they're silent, and they're sustainable. Electric cars are a beacon of hope in a world grappling with climate change, offering a greener, more sustainable alternative to their gas-guzzling counterparts. The environmental benefits of these vehicles are indisputable. They produce zero tailpipe emissions, reducing air pollution and helping us breathe easier. They are also more energy efficient than conventional cars, converting over 60% of the electrical energy from the grid to power at the wheels, as compared to a mere 20% for vehicles running on gas. But it's not just about the environment. Electric cars are also making a strong economic case. As battery costs continue to fall, electric vehicles are becoming more affordable, leading to increasing adoption worldwide. And let's not forget the cost savings in terms of fuel and maintenance. However, electric cars are fundamentally different from their conventional counterparts. Instead of an internal combustion engine, they use an electric motor. Instead of a gas tank, they have a battery pack. And instead of a transmission, they use a simple one-speed unit. This shift in design is not just a technological innovation, it's a paradigm shift in how we think about and use vehicles. Now that you understand why electric cars are gaining traction, you might want to know how they work. Intrigued? Stay tuned. Electric cars operate on a simple principle: converting stored energy into motion. At the heart of every electric vehicle, there's a large battery pack. This battery stores the electricity that powers the car. But how does this electrical energy get transformed into the mechanical energy that moves the wheels? Well, that's where the electric motor comes in. The motor takes the electricity from the battery and converts it into power that can turn the wheels. The controller, another key component, governs how much power goes from the battery to the motor. Think of it as the car's brain, regulating the flow of energy to keep everything running smoothly. Then there's the charging system. This is how the battery gets its juice. Just like you'd plug in your smartphone to recharge, you plug in your electric car to refill its battery. These components work together seamlessly to power the vehicle. But how exactly do they do it? The heart of an electric car is its battery, and the motor is its muscle. Now let's dive a bit deeper into the inner workings of these two essential components. First off, the battery. Think of the battery as a large energy storage unit. It's like a reservoir, holding on to the electrical energy until it's needed. When you plug your car into a charging station, you're essentially filling up this reservoir. The battery in an electric car is a rechargeable lithium-ion battery, similar to what you find in your smartphones and laptops, but on a much larger scale. These batteries are favored for their high energy density, long lifespan, and ability to recharge quickly. Now, let's talk about the muscle of the car, the electric motor. This is where the magic happens. The motor takes the electrical energy stored in the battery and converts it into mechanical energy. This is achieved through the principles of electromagnetism. When electricity is applied to the motor, it creates a magnetic field that interacts with permanent magnets, causing the motor to spin. This spinning motion is then translated into the rotation of the wheels, driving the car forward. But how does the car know how much power to send to the motor? That's where the controller comes in. The controller is like the brain of the car. It takes input from the driver, such as pressing the accelerator pedal, and determines how much power to send from the battery to the motor. The harder you press the pedal, the more power the controller sends to the motor, and the faster your car goes. And after a long drive, when the battery's energy starts to run low, it's time to recharge. The charging system of an electric car is designed to replenish the battery's energy storage. It takes power from an external source, like a charging station or your home's electrical grid, and feeds it back into the battery. So that's a basic rundown of the inner workings of an electric car, but there's more to it than meets the eye. Electric cars are not just about batteries and motors, they are about smart technology. Indeed, an electric car is a marvel of technology, housing advanced features that go far beyond basic functionality. Let's explore a few of these. Regenerative braking, for instance, turns the tables on traditional braking systems. When you apply the brakes in an electric car, the electric motor runs in reverse to slow the car down. converting that kinetic energy back into electrical energy that recharges the battery. It's a brilliant way of regaining lost energy. Then there's the energy management system. It's like the brain of the electric car, constantly monitoring and optimizing energy use to ensure maximum efficiency. It manages the power flow between the battery, the motor, and all other electrical components. And let's not forget about the connectivity options. With features like remote monitoring and control, over-the-air updates, and advanced navigation systems, electric cars are truly smart cars. These smart features make electric cars not just eco-friendly but also user-friendly. So, you see, electric cars are more than just a trend. They represent a shift in how we think about and use transportation. We've journeyed from the future of transportation to understanding the basics, delving deeper, and even going beyond the basics. We've discovered that electric cars operate on a simple yet efficient principle. They convert electrical energy stored in rechargeable batteries into mechanical energy, which then powers the wheels. This simple operation eliminates the need for fuel, making electric cars a cleaner and greener alternative. Moreover, we've seen that the key components of an electric car, including the motor, the battery, and the controller, all work together harmoniously to give us a smooth and quiet ride. But the importance of electric cars goes beyond their operation. They are paving the way for a sustainable future, reducing our carbon footprint, and revolutionizing our transportation systems. Next time you see an electric car zoom by, you'll know exactly what's going on under the hood. Until then, keep exploring, keep learning.